We're now going to move on and talk about how to solve a system when I don't just have x and y, but I also have a third variable, usually z. So what we're going to do in these is we're basically going to do elimination 2 or 3 times and then do substitution twice in order to get all my answers. So instead of having an answer that's x comma y, your answer is going to be x comma y comma z. And so this first example in your notes is already typed up, and so we're just going to talk through it. So don't fast forward, but this is really important to be able to know and understand all the steps without worrying about writing it down. So when I'm trying to eliminate variables, what you're looking for is for the coefficients to be the same. So if I look at x's, they're not the same, y's, they're not the same, but z's, they are the same. So my first step is to get rid of a variable, and in this problem, z is going to be the easiest variable to eliminate because they already have the same coefficients and I already have opposite signs going on. So what I'm going to do is, since the 2x minus y plus z is the only one that has a positive z, I'm going to use that for both sets of my elimination problems. And then I'm going to split up number 2 and number 3. Are there other ways to do this? Absolutely. They're just going to take a while. So the shortest way is to look for the variable that has the same coefficients in every equation and to split it up based on the positive and negative signs so I don't have to worry about those. After that, we're going to do elimination. Since these equations are nice, and believe it or not, and already have the same coefficients and opposite signs, I can go ahead and just add straight up and down. So that gives me 3x plus 2y. My z's eliminate and I get 15. On the right hand side of equations, I add and I get 6x plus 0y plus 0z equals 18. And now I'm happy because I also already eliminated y. So I can solve for x, and that gives me that my x value of my point is going to be 3. So I know my x value is 3. After we've done 2 sets of elimination, now would be where, if I needed to, I would do another set of elimination with my 2 equations that I got. But since I already have x equals 3, what I can do is substitute the x equals 3 in for x in my other equation that I got. And when I do that, there's all this work, and I get that y also is 3. So now I have my x's, I have my y's, and so all I can solve for is c. It doesn't matter which equation I use for the next part, but I just chose the first equation, equation number 1. So you just write that down, and this is normal how we substitute to find the last variable. So 3 for x, 3 for y, and solve for z, and get that z equals 1. So this next one, we need to look and see what variable we want to eliminate first. So I notice my x's are the same coefficients. That's good. Y's aren't, z's aren't. So I'm going to stick with x. And here I notice that I have 1 positive x and 2 negative x's. So I'm going to put the positive x as one of my equations in both sets of problems. And then I'm going to move equation 2, I'll put here, and equation 3, I'll split and put over here. Now we're going to do elimination with those 2 systems, and I've already set it up so that my x's are going to cancel and give me 2 variables. So x minus x is 0x, negative y plus 2y is y, negative 2z plus z is negative z, and 4 plus 1 is 5. On the right side, x minus x is 0x, negative y plus y is 0y, negative 2z minus 3z is negative 5z, equals 15. And once again, I'm really happy because my right equation, I can finish solving for one of my variables. So I get z equals negative 3. Now I can bring together these 2 equations. So y minus z equals 5, and we have z equals negative 3, so y minus negative 3 equals 5. Minus a negative is going to be the same thing as a plus, so y plus 3 equals 5, which means y equals 2. So I now have that y equals 2 and z equals -3. So 2, -3, and I just choose any of my equations original equations to write this down. So since I can see the -x plus 2y plus z equals 1, that's what I'm going to use because I can't see other ones on my screen. But it doesn't matter because remember, a solution means it makes all of my equations true at the same time. So I get -x plus 2 times 2 minus 3 equals 1. So -x plus 4 minus 3 equals 1. -x plus 1 equals 1, so x is going to be 0. So now on this last one, I haven't given you what two equations to use, so let's talk through the process once again. Do my x's have the same coefficients? No. Do my y's? Yes. Do my z's? No. So that makes it straightforward. I'm going to choose to eliminate y. So I'm going to look at y's. I see I have one variable that has a positive y, so I'm going to put that in both. X plus y plus 3z equals -3. And then my other, put it for my other set of equations. Then I'm going to use the first equation, x minus y plus z equals -1, and third equation, 2x minus y plus 2z equals 0. Now, all of the examples we've done were really nice and immediately had a variable that canceled. What if that doesn't happen? Well, then you have to do our normal switch and simplify, then you got to multiply with one of the variables, and you just choose which one you think is going to be easiest. So let's look at the first equation. X plus x is 2x, y minus y cancels, 3z plus z is 4z, equals -3 minus 1 is -4. Same thing over on the right. X plus 2x is 3x, y minus y is 0y, 3z plus 2z is 5z, equals -3. So this is the first time that one of my variables hasn't been solved for in one of these. So now this comes down and it's an elimination problem like we have been doing in class. So I take this equation, 2x plus 4z equals -4. And I take the other equation, and I've, of course, run out of colors, so we'll just use red again. 3x plus 5z equals -3. And we have to solve it old school. So I'm going to multiply my first equation by 3 and my second equation by 2, and I'm going to need to change signs. So I get 6x plus 12z equals -12. 6x plus 10z equals -6, and then I need to change all the signs in one equation, so I'll use the second equation. And yes, these are kind of forever long problems, so am I going to give you a lot of these on a test? No, I'll just do 1 or 2. Okay, 2z equals -6, so z equals -3. Now I'm going to plug it into one of these ones that I've written down here. So I'll use the first one. 2x plus 4 times -3 equals -4. I don't want to go all the way back up to one of the original problems because those had y, and I still don't know enough information for that. So 2x minus 12 equals -4. 2x equals 8. X equals 4. So I have 4. I need to solve for y. I have -3. And now I'm going to substitute into one of my original equations, 4 for x and -3 for z. It's hard to keep all these in mind. Okay, so I'm going to copy down just the bottom equation, 2x minus y plus 2z equals 0. So that's going to be 2 times 4 minus y plus 2 times negative 3 equals 0. So 8 minus y minus 6 equals 0. 2 minus y equals 0, which is going to tell me that y has to equal 2. So my point is 4, 2, negative 3.